Good evening, and welcome to Star Chat, the podcast where we explore the wonders of the universe and the latest developments in space exploration. I'm your host, Carl. As we gaze up at the starry sky, we're reminded of the vast expanse of space that lies before us, full of mysteries waiting to be unraveled. And tonight, we begin with a story that highlights the challenges and complexities of space travel. NASA has declared the Lunar Trailblazer moon orbiter dead, a mission that was intended to pave the way for future low-cost small satellites to conduct innovative science on the lunar surface. Launched atop a SpaceX Falcon 9 rocket on February 26, 2025, the 440-pound moon orbiter went dark just a day later, leaving NASA's team scrambling to re-establish contact. As we ponder the fate of Lunar Trailblazer, let's take a step back and consider the bigger picture. The moon, our closest celestial neighbor, has been a constant source of fascination for humanity. From the early Apollo missions to the current Artemis program, our species has been driven to explore and understand the lunar surface. And yet, as we strive to return humans to the moon and establish a sustained presence, we're reminded of the immense challenges that lie ahead. The Lunar Trailblazer mission was designed to test new technologies and strategies for exploring the moon, with a focus on low-cost and efficient operations. While the mission may not have achieved its intended goals, it has provided valuable lessons and insights that will inform future endeavors. As NASA so aptly put it, mission experiences like Lunar Trailblazer help us to learn and reduce the risk for future, low-cost small satellites to do innovative science as we prepare for a sustained human presence on the moon. As we reflect on the story of Lunar Trailblazer, let's not forget the billions of years of cosmic history that have shaped our universe. The moon, formed from debris left over after a massive collision between Earth and a Mars-sized object, has been orbiting our planet for eons. And now, as we strive to return humans to its surface, we're reminded of our place within the grand tapestry of space and time. So let's take a moment to appreciate the complexity and beauty of space exploration. From the intricate dance of celestial mechanics to the cutting-edge technologies that enable us to venture forth into the unknown, every mission, whether successful or not, contributes to our collective understanding of the universe. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. We're diving into the fascinating world of astronomy and astrophysics. Today, we're exploring a groundbreaking study that sheds light on the formation of planetary systems around sun-like stars. Researchers have made a remarkable discovery, suggesting that approximately one-third of these stars are born with misaligned planet-forming disks. Imagine a cosmic dance, where the disk of gas and dust surrounding a young star is not aligned with the star's equatorial plane. This misalignment can have significant implications for the formation of planets and the ultimate architecture of the planetary system. The study analyzed a sample of 49 stars, using data from various sources, including the TESS input catalog. The team found that the distribution of disk inclinations is not random, but rather follows a specific pattern. They used advanced statistical models, such as kernel density estimation and hierarchical Bayesian modeling, to reconstruct the underlying distribution of disk inclinations. The results indicate that about 30% of sun-like stars have misaligned disks, which challenges our current understanding of planetary formation. But what does this mean for the search for life beyond Earth? Could these misaligned disks lead to the formation of exotic planetary systems, with conditions that are favorable for life? The answer remains unclear, but this study opens up new avenues for research and raises exciting questions about the diversity of planetary systems in our galaxy. As we continue to explore the mysteries of the universe, we're reminded that there's still so much to learn about the complex processes that shape the formation of stars and planets. The discovery of misaligned planet-forming disks is a significant step forward in our understanding of the cosmos, and we can't wait to see what future studies will reveal. Stay tuned for our final story of the day, right here on Star Chat. Welcome back to Star Chat. As we wrap up today's episode, I'd like to take you on a journey to our closest celestial neighbor, the Moon. You may have heard recent news about NASA's plans to build a nuclear reactor on the lunar surface by the mid-2030s. But why, you might ask? Is this a priority for the space agency? Imagine a future where humans establish a long-term settlement on the Moon. A reliable source of energy would be crucial for sustaining life and supporting various activities, from scientific research to resource utilization. That's where the nuclear reactor comes in, providing a steady supply of electricity to power the settlement. However, as we delve deeper into the story, it becomes clear that the motivations behind this project are not solely driven by scientific curiosity or a desire to expand humanity's presence in space. Geopolitics plays a significant role, with NASA aiming to beat China and Russia in establishing a lunar reactor. The idea of a keep-out zone has been mentioned, where the first country to set up a reactor could potentially claim dominance over a region on the Moon. But here's the thing. International law is unclear about such zones, and the Outer Space Treaty explicitly prohibits claims of sovereignty over any land in space. So, what's the real purpose behind this endeavor? Is it truly about advancing human knowledge and exploration, or is it a matter of national pride and one-upmanship? As we ponder these questions, let's not forget the challenges NASA faces, from budget cuts to workforce reductions. Can the agency really afford to prioritize a lunar nuclear reactor at this time? The answers, much like the stars in the night sky, remain elusive. That's all for today's Star Chat. Remember to like, share, and subscribe. And until next time, remember to keep looking up at the stars.